Hey there. Let's talk about a word you probably use a dozen times a day without even thinking about it. The word same. Seems pretty straightforward, right? Well, it's not. Hiding inside that one little word is a really fascinating logical puzzle, one that can trip up just about anyone.
Okay, let me ask you something. Let's say you and I both drive a black Tesla Model 3. If someone asks us, hey, do you two drive the same car? What's the right answer? I mean, you could say yes, of course, because they're the same make, model, and color. But you could also say no, because, they're two completely different cars parked in two different driveways. So, which is it?
And look, this isn't just us playing with words. This little problem gets right to the heart of a huge question in logic and language. How can one single word hold two totally distinct, almost contradictory meanings? To get to the bottom of this, we've actually got to travel way back in time, over 2,000 years ago, to ancient Greece. Because it was the philosopher Aristotle who first really rolled up his sleeves and took on this problem. He looked at all this confusion and gave us a beautifully simple way to clear it all up. So what was Aristotle's big idea? Well, it was brilliant, really. He just recognized that we're not dealing with one idea here. We're trying to pack two completely different concepts into one word. So he broke sameness down into two logical categories. And these two categories solve our car paradox perfectly.
Okay, let's start with the first and most precise type of same. Aristotle called it sameness by number. Now, this is identity in its most absolute, most literal, strictest sense.
Numerical sameness means you are talking about one and only one individual thing. Not two things that are just alike, but the one and only object. When something is one by number, it is literally the one and the same thing. There are no copies, no duplicates, just the one. So we're talking about one single object. This is the idea of absolute identity, where A equals A. And that leads to this really powerful rule with a kind of clunky name, the principle of unrestricted substitutability. But the idea behind it is actually super simple. If two things are truly, numerically one and the same, then you can swap one for the other in any sentence, and the sentence will still be true. Aristotle himself put it perfectly right here. He's basically saying that if two things are numerically the same, then every single thing that is true about one of them must be true about the other. Think about it like this. Superman and Clark Kent. If they are numerically the same person, then you can't say Superman can fly, but Clark can't. It doesn't work. Every single property has to match, no exceptions. All right, so that's a super strict way to be same. But what about the way we usually use the word? Well, that brings us to the second type, which Aristotle called sameness by species, or by kind, and this one is the key to our whole Tesla problem. Sameness by kind, or species equivalence, is what's happening when we're talking about two or more different things that just happen to belong to the same category. They're not the one and the same object, but they are the same kind of object. And this is the big difference, right? Suddenly, we're talking about two or three or a million different things. They all share a category, like black Tesla Model 3, but they absolutely do not have to share all their properties. My car could have 50,000 miles on it and a dent in the bumper, while yours is fresh off the lot. They are the same kind of thing, but they are not the same thing.
So we've got these two kinds of same, numerical and by kind. So what? Why does this ancient idea actually matter to us today? Well, because when you put them side by side, you get this incredibly powerful tool for clear thinking. Let's just put them right next to each other. On one hand, you have numerical sameness. That's strict identity. It's always about one single object, and all of its properties have to match. Then you have species equivalence. That's the broader sense. It's about multiple objects, and you can only really swap them when you're talking about the things they have in common. This chart just nails it down perfectly. For numerical sameness, you're always talking about exactly one object. All properties match. It's the whole one and the same idea. But for species equivalence, you're talking about two or more things where only the essential stuff matches. These are what you might call such as objects. They are examples of the same kind. And that's the real magic here. Once you see this split, you just can't unsee it. By giving us these two different buckets for the word same, Aristotle didn't just solve some dusty old philosophical riddle. He basically handed us a software update for our own brains, letting us think and communicate with way more precision. So, what's the one big thing to take away from all this? It's that this simple little word, same, is always doing one of two jobs. It either means one and the same object, or it means the same kind of object. And just knowing the difference, that's the key to avoiding a whole lot of confusion. So I'll leave you with this challenge. Now that you're armed with Aristotle's little secret, just start listening for it. In conversations you have, in things you read, even in your own head. How often do you catch yourself or someone else using the word same? And more importantly, can you tell which of the two meanings they're really using? I think you're going to be surprised.